All right. So, how to interpret a pedigree. What is a pedigree, first of all? Pedigree is a diagram that the purpose of it is to trace, that traces a single genetic disorder or characteristic, right? But usually you're tracing disorders through a family tree. And I think these are kind of fun. They kind of become little puzzles. And as soon as I start drawing the symbols, you're going to go, oh, yeah, that's right, I remember that. So they're not really hard, but of course, AP Biology can make it hard. Because sometimes they'll show you a pedigree and they'll say, okay, would this be autosomal recessive, or would it be autosomal dominant? Would it be sex linked? Would it be linked? So I'll try to confuse you with that. If you're really hot stuff, you'll know the difference between something that's mitochondrial DNA linked versus nuclear DNA. So we won't go into that. So simple, starting simple. A square is a male. A circle is a female. This is a marriage or a mating. A line coming down and having several lines coming off of it like this would indicate that these are the children of this marriage. This would indicate that this is this first child, because it goes from left to right in terms of order of birth. This first child is affected by whatever disorder you're tracing. And then this would indicate that this girl grew up and married somebody, and they had a child, right? So a lot of times they'll number these for you on a diagram, like that. And then they'll say something like, all right, individual number 1 and individual number 7, how are they related? Who is individual number 1 as related to number 7? Number 1 is number 7's grandpa, yes. Yes, number 1 is, yeah, number 7's grandfather. Oh, has my screen full, Shorsten, has it? Well, no, because I just haven't written anything new. I think you're okay. Okay. That's okay. I just haven't drawn anything for a moment. So this would be great. See, yeah, I can see it's gone. So this would be grandfather to number 7, right? And then how many children does this couple here, have? How many children do they have? They have 3 children, right? Because number 6 is not one of their children. Number 6 married one of their children. Okay, so you guys got it. All right, so that's basically how you're doing this. Now, if I were to add a few things here, maybe I will add a few things here, just to test you, because I think it would be good. What if we also had another boy over here? And the boy is also affected. That there. Okay. Greatest child lines. All right. Maybe that's a child is not, they're not married, they're brother and sisters, okay? All right. And let's call this boy number 8. And let's say that we're tracing a disorder here. What do you think the inheritance patterns of this disorder would be? Would this be autosomal or would it be sex linked? What would you guess? Yes, sex linked. Very good. Okay. And the reason why that would be a very good hypothesis is, and again, we're only talking about a single trait being traced here, so we're not going to talk about gene linkage. We're just talking about sex linkage, which you remember is very different. So, for example, if I were to draw the genotypes of each of these people, and I know that it's sex linked because the males seem to be more affected than the females, number 3 and number 8, the males in this lineage seem to be more affected than the females. That's a big clue that it's sex-linked. And in fact, if this were tracing the disorder hemophilia, which is a famously sex-linked disease, right? Hemophilia, yes. So if this were hemophilia, then H would be normal, right? Normal blood clotting. And little h would be hemophilia. Then I would be drawing the sex chromosomes of these individuals before I would be drawing their allele, right? And most likely, like for example, if woman number 2 was in fact Queen Victoria was a famous carrier of hemophilia. So her alleles, we know now today, were big H, little h, and that little h traveled through and affected her boys, and then affected the boys of all of the sons of Europe, because they all married her daughters, and then those daughters were carriers, and they took hemophilia everywhere, including into the Russian families. So I just thought I'd make that clear, that you know that she must be a carrier, because that's the only way that this boy could have inherited hemophilia, right? And then also we know that this boy, excuse me, that this girl also has to have been a carrier. This girl here also must have been a carrier, because this boy got his Y from his dad, and he could only have gotten that little h from his mom. So that's the way you tease apart these problems in terms of pedigrees. I think that's all I need to tell you about that. So I'm going to stop that recording.